2 weeks ago, we talked about forces, Newton's 3 laws and forces. And today we're gonna move on to motion in 2 dimensions, which is our last unit. And if you remember, our first unit was actually motion in 1 dimension, but now we're gonna look at motion in 2 dimensions. So instead of just one direction, it's gonna be 2 directions. And today might get a little rough because this is a bit complicated because we're going to be doing like vector addition and subtraction. And if you remember, a vector is something with magnitude and direction. So yeah, there will be some more advanced math in here. And if you don't understand like any of it, that's totally fine. It's just kind of to introduce you. So this is just like an introduction. You don't have to understand everything, but it's just kind of good to just look at things and like get a taste of what it's like. So yeah, please motion in 2 dimensions. It's like if you have something moving in one direction and then moving in the other. So because you're changing directions, you'll need to know how to do vector addition. And basically how you do vector addition is you use this thing called the head to tail method. And it's really simple. It's literally just what it's named. So if you have like over here, you ignore this 10.3 units arrow. So first you have this arrow going this way, and you have this arrow going straight up. So how do you add 2 arrows together? Basically, you just put one at the tail of the other, one head, so this arrowhead at the tail of another. And you could put this head at the tail of this, and you would still get the same resulting vector, which is like this vector, and it's called the resultant vector. So basically this is the vector you get when you add 2 vectors together. And vectors basically is like, they might sound complicated, but what you want to think of them as is just arrows that have a number basically. So over here you can see this resulting vector, this resulting arrow. It can be measured with this ruler, and it shows that it's 10.3 units. And it can also be measured with this protractor. And if you don't know, protractor is something that measures angles. So like how like steep something is, you can use your protractor to measure it. Basically, it's like a ruler that goes up and down. The purpose of these 2 things is to show that this arrow, this is a vector, it has a magnitude, which is this 10.3 units, and also has a direction, which is this angle right here. So angles can also be used to show direction. And this may be overwhelming and a little complicated, but it's okay. You don't have to understand it right now. It's just like an introduction kind of. Now we're gonna do an example, and hopefully this will help make everything make more sense. How to graph points and on an XY axis, then this will look familiar. If the example says add vectors A and B, so just A plus B. And what does that equal? And here are vectors. Vector A is 9.6 meters in the X direction, and then 14 meters in the Y direction. Vector B is negative 4.6 meters in the X direction and negative 19 meters in the Y direction. Basically, it's just a lot of drawing of like your XY axis, right? You probably learned this before. If not, that's fine. It's just numbers on a line and seeing like where they line up. So this is the Y axis because it goes up and down, and this is the X axis because it goes right to left. So for vector A, the X is 9.6 meters. So we can just say like this is about 10 meters. This is 9.6 meters. If that's about 10 meters, then 9.6 is really close, kind of like right there. So 9.6 on here, and then on the x-axis, and then it says 14 meters on the y-axis. And if that's about 10, we're going to say this is about 10 meters. It's not very accurate. So then 14 is probably around like here, just 0 in the middle. This is 0. Just kind of draw a line from both sides. And you see that it intersects here. So this is where the point is. And the vector starts at 0. And for vector, like to draw an arrow, you need 2 points, right? So one point is going to be here at the 0, which is also called the origin. And the other point is going to be right there, that point that we just drew. So it's going to make an arrow like this. So there you have it. We've drawn our very first vector. It's not that hard. It's just basically 2 points. And now we're going to draw vector B. Now, you know, like this is about -10 meters because we're in the opposite direction. So negative 4.6 is around here. And then if that's 10, -10 is probably around here. And so we're going to do the same exact thing that we just did earlier by drawing 2 lines and seeing where they cross. This line is here and this line is here. So that's where vector B is. So this is vector A, and the arrow can show that it's a vector, or you can bold it. And then this is vector B. So how do you add these 2 vectors? So remember earlier we said there's a method called the head to tail method, where you put the head of one vector at the tail of the other. So over here, we're going to put the head of vector A at the tail of vector B. But how are we going to do that? We're going to basically move vector B. So now I'm going to draw vector B in blue. So it's kind of more obvious. So basically you just copy this arrow, you kind of copy and paste it. So I'm going to try my best to make it look like the same. And it would probably look something like this. So this is still vector B, but so this is the same vector, but you just moved it. It's the same arrow, but you just moved it basically. And so now you have a head to tail right there. And now you can draw the resultant vector, which I'm going to draw in green. And I use 2 arrows to show that it's a resultant vector. So how do you know what this point is then? Because that's how you show that it's a vector. You need to find where the other point is, because one point starts at 0, 0. The other point ends somewhere. So how do you find this point? It's actually really simple. So you just add these 2 numbers together to find the x, and then add these 2 numbers together to find the y. 9.6 plus, and this is negative 4.6. When you add a negative, it's the same thing as subtracting, right? So it's just going to be 5.0 meters for the x, okay? And then for the y, you're going to add these 2 numbers together. You're going to get 14.0 plus negative 19, which remember is just the same thing as subtracting. So what's 14 minus 19? You got the 5 for that one, right? Yeah. So, and what's 14 minus 19? So yeah, just very simple, just adding and subtracting. So what does this mean? You have x is 5, y is negative 5. So that means that this point right here, this vector, the x equals, so this is x, equals 5.0 meters, and the y equals negative 5.0 meters. So this is 5 meters, and this line right here is negative 5 meters. If you looked at the arrow we drew, well, I drew it, I kind of drew it bad, but it sort of makes sense because this is almost halfway between 0 and 10, but this I did not draw well. So it doesn't look halfway, but it should be like halfway. So maybe the point should be like more like here, kind of. You would add arrows, basically how you add vectors. So yeah, that's our answer right there. 5 and then negative 5. So that's a plus b. The resulting vector has a coordinate of 5 and then negative 5. So yeah, that's our first example. So we're gonna do a check your understanding things. There are 2 vectors A and B. So you have 2 arrows A and B. The head of vector A touches the tail of vector B. The addition of vectors gives a resultant vector C. So if you add A and B, you're going to get a resultant vector called C. Can the addition of these two vectors be represented by the following two equations? First equation is vector A plus vector B equals vector C. And the second one is vector B plus vector A equals C. And so the difference is the order of these two. Do you add the head of this to this tail, or do you add the head of B to the A tail? One answer is A. The answer is A. Basically, if you have vector A, let's make it blue. If vector A is like this is A. This is vector B. What's the resulting vector? Resulting vector is like this, right? So this is C. So that's what it looks like if you add A plus B. But what if you did B plus A? So if you did B plus A, it would look like this. You would go like this first. So this is B. And then you just scoot over a little. Plus A. So what's the resulting vector? It's like this. This is C. And if you look at both of these C's, they're the exact same. They're pointing in the same direction and they're the same length. And that's A and Y. You are right. That A is correct. That if we add the same two vectors in a different order, it will still give the same resultant vector. So we just added vectors. Now we're going to talk about subtracting vectors. And I'm just going to say, you also use the head to tail method. So the same thing we've been doing earlier, except when you add, like when you subtract the vector. So if you do like A minus B, like even in algebra, in normal math, if you do A minus B, you know that A minus B is the same as A plus negative B, right? So as you can see over here, this image, it shows B, the arrow B in this direction, and then negative B in that direction. So for vectors, if you just stick a negative in front of it, then the arrow is going to flip in direction, flip 180 degrees. Okay. If you wanted for this one, this was a vector for this particular one. It was vector A plus vector B equals vector C, right? But what if we wanted to do vector A minus vector B? So how we would draw that instead is we'd still draw A the same way because it's still positive, like this. We're not subtracting, we're just adding A. And then how would we draw B? We'd have to draw B differently because it's negative this time. So if it's a negative B, what happens to the arrow? It gets flipped. So instead of pointing up, it's going to point down. It's going to be what B looks like. And then the resulting vector is going to look like this. It is kind of like this C, but kind of pointing the opposite way. So this is what you get if you did A minus B, and that's what you get if you did A plus B. So you just flip the B right here. So why are we doing so many things about vectors? So if you remember what we've learned earlier in this class, are multiple things in physics that are vectors. So one of them is actually on the screen, the F. So but there are other things. So can you tell me at least one thing that is a vector quantity in physics? Okay, I'll just say one thing I've thought of that is a vector quantity in physics. So as you can see on the screen, the F there stands for force. So force is something that's a vector in physics. So basically, what does that mean? It means that force has a direction and it has like a number, a magnitude. So it has a direction and a value. And then something else would be velocity, because that's how fast something goes. So that's a number. And then also in what direction, like positive or negative direction, or like north, south, east, or west. So those are just a few vector quantities, and everything that's not a vector quantity is a scalar quantity, which, like, for example, would be mass, like how much mass, which is how much stuff is inside of you, basically. You only have a number to represent like how many kilograms you are. You don't say like I'm like 20 kilograms east, like that does not make sense. So it's just a number that's scalar. And then remember, vector is something that is a number and also has a direction. So as you can see here in this picture down here, it shows an arrow, and it has, each arrow has like a length. So the length of the arrow represents the magnitude of the force, and the direction is the direction. So that's why we're learning so much about vectors, because they represent a lot of things in physics, and you need to know like vector addition and subtraction, which is what we're learning today. But it's also if you want to add more complex vectors, you can't just draw like what we did earlier. So you're gonna have to know something called the Pythagorean theorem, which is probably something you don't learn until middle school, but I'll just show you what it is right now, so you don't have to understand. So this is like a little animation that shows basically what the Pythagorean theorem is. And then the theorem is like kind of an idea that is known to be true. So this is a discovery made by Pythagoras, who was a mathematician from over 2,000 years ago. And what he, or I think some of his students, discovered was that if you have a right triangle, so what's a right triangle? It's a triangle with one corner that's 90 degrees. So like this is a right triangle right here, because that corner is 90 degrees, a square basically. So basically you can fit a square in the corner. That's a right triangle. And then what he discovered was that if you made a square on each side using like this side of the rectangle triangle, you have this square, and then this side of the triangle you have this square, and that side of the triangle you have this square. You can check out this animation, it's really cool. Squares on each side, you can move it and reshape it. The area is still the same. Like this is like a squashed square basically. It's still the same area as the square from before. They just kind of like made it longer but shorter. But the important thing is these two squares that were here earlier fit in the big square that was made from the diagonal side of the rectangle. So that's kind of crazy, right? So it's the exact same area as the biggest square. The two smaller squares put together have the exact same area as the biggest square. So what can we like get from this? You probably know that the area of a square is one side times the other side, which are both equal, right? So if this side has a length of A, of the square has a length of A, that side has a length of A also. The area is going to be A times A, right? This area of the square is going to be A times A, which is also A squared, right? And that's the same for this square. B times B is equal to B squared. This side, C times C equals to C squared. And so what we said earlier was this square, the area of this green square, plus the area of this blue square right here equals the area of this big red square. So from this, we have an equation, which is A squared plus B squared equals C squared. So that's going to come in handy, but that equation can be rearranged as C squared equals A squared plus B squared, right? So if you take the square root of both sides, you get C, because you took the square root of C squared, it's C, equals to square root, a giant square root over A squared plus B squared. So C equals square root of A squared plus B squared. And we're going to be using that later right here. So if you see here, if our forces make like a right triangle, see, because you could fit like a 90-degree angle here, we can use the Pythagorean theorem. So yeah, like I said earlier, C equals square root A squared plus B squared. So for this, you can just substitute f tot, which is f total, as C, because it's the longest side, and f1 and f2 can be A or B. It doesn't really matter, as long as it's not the longest side. So if f total squared equals f1 squared plus f2 squared, which is what we know from the Pythagorean theorem. You took the square root of both sides, you're going to get f total equals to square root of f1 squared plus f2 squared. And this will give you the magnitude or the length of this arrow. And hopefully that makes sense, because this is basically like a triangle. So you can use a rule for triangles for something that's like a triangle. Moving on, we're gonna do an example with vectors. This might get a little bit complicated. Also, is two people pushing a person, and you just put the head of this vector to this tail, right? So that's what you get. Yeah. And that's how you find out where this person in blue will move. Because you add the arrows together, and now you know the person will move in that direction. So this is going to get a little bit complicated, because there's going to be some trigonometry, which is a very big and scary word for something that's actually not that scary. And this is really new to you, because this is not something you learn in 4th grade. It's something you learn in like maybe 7th or 8th grade. So don't worry. This is just something you can like take a look at. And so before we do this problem, I need to show you something. So I'm just gonna add a page. So trigonometry is kind of the study of angles and triangles. So using trigonometry things, you can find out a lot of information about triangles most of the time, but which will also help you find out things more about other things. But mostly it's about triangles, as you can see, like the TRI there. So the first thing for this specific rule we're coming up with, okay, for this specific rule, we're just going to be looking at lots of triangles for now. So nothing about physics yet. This is more math. So if you have a right triangle, and this is a right triangle, right? Because you can fit the square in the corner, basically 90 degrees. And if you have, this is A, this side is the length of A, this side is the length of B, this side is the length of H. And this angle, we're going to call it something called theta. So theta is just like a Greek letter that we don't have in the usual alphabet, but for some reason, whenever we talk about triangles, we like to use theta for the angle. Also, these three things, one is called sine, another is called cosine, and the other is called tangent. And from here, you can see, just based on the words, this word and this word are kind of similar, because they both have the same like ending kind of. So from that, you can realize these are probably related, and they are kind of related. They're almost the same, actually, in a way. So what is sine? Sine is abbreviated as like this, SIN sometimes, and then cosine is abbreviated like this, and tangent is abbreviated like this. So when someone says sine theta, what is sine theta of this triangle equal to? So sine is like, you can think of it kind of like, it's kind of like an operation, like something you do to this angle, and then it'll spit out a number. And how you find that number is that sine theta is always equal to the opposite of this angle. So what's the opposite of this angle? They go directly across. Opposite is not touching this angle. Like you can see B, the side B and the side H is touching this angle. So it's not B and H, it's A. The opposite is A. A over the longest side. That's sine. Cosine theta is equal to what's touching it. That's not the longest side. So this one, this is the adjacent side because it's next to it, over also the longest side. And then tangent theta is equal to sine theta divided by cosine theta, which is equal to A over H divided by B over H. And this is the same thing as A over H times, you just flip this to bring it to the numerator, so H over B. So you got equals A over B, which is the opposite side divided by the adjacent side. So how do I remember all of this? You just can remember this like kind of acronym, SOHCAHTOA. So this means sine is the opposite side and O divided by the hypotenuse, which is the longest side. Cosine is the adjacent side, so the ones that's touching, divided by the longest side, the hypotenuse. And tangent is the opposite side divided by the adjacent side, which is the one that's touching. Or you could also remember, one of my math teachers taught me, some old horse came hopping through our alley. That works too, but that's also kind of long. So I don't know, whichever one works best for you. We kind of need, actually, one last thing. So from this, sine theta equals A over H, right? So what if we wanted to find A and we had theta and we had H? So sine, like of an angle, is just something you can type into your calculator and it'll spit out numbers for you if you have theta. So it's like, yeah. So if you have theta and you have H, then you can find A. So what does A equal in terms of that? You can multiply both sides by H, and you'll get A equals H sine theta. And then the same is for cosine theta. If you multiply both sides by H, you get B equals H cosine theta. So we're going to be using these two equations later on. Now we can go back to vectors and try this example. This is probably very confusing, but it's okay. Okay, so first there's a person who walks 25 meters in a direction 49 degrees north of east. Then he walks 23 meters heading 15 degrees north of east. Finally, he turns and walks 32 meters in direction 68 degrees south of east. So the first thing you might want to do is draw a compass. Well, after drawing the compass, is that you want to draw like a big graph. So what you do is, this is the Y, that's the X, right? First, the question says, this person walks 25 meters in a direction 49 degrees north of east. So where is 49 degrees north of east? Well, this is the Y-axis, like up here, positive, is basically north. If you can look at these two, and they're the same thing. So this way's north, this way's east. So northeast is like this, but it says 49 degrees north of east. And we know that if it goes straight up right here, it's 90 degrees. So 49 degrees is almost halfway, because half of 90 is 45, right? So this is about 25. We're going to say this is about 49 degrees, and this is 25 meters. So that's how the person first walks. He walks like this. Next, he walks 23 meters heading 15 degrees north of east. So it's the same direction. And how you can do this is you can draw like another little graph thing. So this way's east, this way's north. 15 degrees is, so this whole thing is 90. So straight up is 90. If you divide 90 by 3, what do you get? 3, you get 30. So 1/3 of this whole thing is 30. And then what's half of 30? Half of 30 is 15, right? So you get 1/6 of this entire thing is 15 degrees. So that's probably what this kind of. And this is slightly less than the first arrow because it's 23 meters. And this is, it's okay. And then next, the last thing he does is turn and walk 32 meters southeast. So we're going to draw our little arrows again. Oh, sorry, little lines again, guidelines. Southeast would be in this direction, right? Because this is north, that's south. Oh, sorry, this is north, this is east, this is south. So it's going to be downwards like this. And it's 68 degrees So it's more than 49 and more than 15. So what's the resulting vector? See how I've been doing everything head to tail? Head, what this angle is, this very tiny angle. We want to know what the angle is, and we want to know how long this is, how long this arrow is, and we're going to call that r. So how do we find r? How do we find the angle theta? So if you split each of these arrows, you can see this arrow is actually has an x component, so one to the right and then one up. So it's two arrows, one to the right and one up. You'll get this arrow. And that last arrow is like this. So it's one arrow down and one arrow to the right. And the one in the middle is also one to the right and one up. So how we're going to add all these vectors is we're going to split everything into small pieces, smaller arrows that are going to the right and going up or down. So thing we did earlier, the trigonometry comes in. This is how we find like so this is A, which is basically how tall the up down arrow is, and then B is how long the right left arrow is. So how do we find the x? Because this green arrow is actually, it looks like this line here. So we're going to find x and y. So how do we find x and y? We add all the x's over here. And then how do we find y? We add all the y's. But we're subtracting this y because this is going in the opposite direction. It's going down. So let's find all the x's first. Equation earlier, we saw that the length, like this one, the right left, is b, which is equal to h, so the diagonal cosine theta. So we're going to go here. This is the same thing as saying for this one, if this was like a triangle, it would be the same thing as saying we're trying to find this long side. That's the same thing as trying to find h cosine theta. So h in this case is 25 meters right here, and then cosine theta is 49 right here, cosine 49. And then you're going to repeat the same thing for all of these because they're all moving to the right. Right, this arrow is also moving to the right, and this arrow is also moving to the right. So we're just going to add. So for this one, the h is 23 times cosine 15. And I'm going to repeat this again because I just can't emphasize it enough. It's okay if it doesn't make any sense right now. For this, the h is 32. And then cosine 68 degrees. And now you're going to add all of this together. How do I add all? First, actually, you have to see, this is a graphing calculator, by the way, so it can graph things. You might use it in the future. You have to see, is this right? So the angle can't be, there are two ways that you can express angles. You can say like what an angle is, like two different units for angles, basically. Like for example, like if you had money, it can be in dollars, which is in America, or in pesos, which is in like Mexico, or it could be in like Japanese yen, which is in Japan. And they're all different values, but they each different currency. So here we have like basically the currency set as radians, which is not what we want. We want it in degrees. So like, because everything here is in degrees. Okay, and then plus, actually I'm gonna put parentheses here, just so we're clear that this is all the same thing. And this is like 25 times cosine 49. Okay, and so, okay. And now we have 23 times cosine 15. And then plus another one, 32 times cosine 68. And that will give us 50.6. For, what was that? That was x. So that's about 50.61 actually meters in this direction. And now we can do the same thing to find y, except for y, we said the equation was instead of cosine, it's going to be sine. So this is like the y because it's up down. Instead of h cosine theta, it's going to be h sine theta. This is going to be 25 sine 49. So it looks really similar. 23 sine 15. Until we get to this one. It's going to be not plus. Yeah, it's going to be different for this one. It's instead of plus, it's minus 32 sine 68. And why is this? This is because for this last one, this last arrow, it's going down and to the right. So you have to subtract. This is in the opposite direction. Whereas these first two arrows, they're going to the right and up, right and up. So all up, and the last one's down. So that's why you have to subtract. And now you just plug and chug. And this is the answer. The answer we get is works right. Okay. So then what does this mean? This means that the y is negative 4.85. This y is negative 4.85, which makes sense because this dot is below this 0 line. Find r then. This is r, right? So we use the Pythagorean theorem, which we talked about earlier. This one, a squared plus b squared equals c squared. So in this case, a squared is this x right here. B squared is this y equals c squared, which is like the r. So what we're gonna do is a squared is gonna be 50.61 squared plus negative 4.85 squared equals to this r squared. So how do you find r by itself? Well, r equals the square root of both sides, because if you square root this side and square root this side, you get r on this side. So r equals square root of 50.61 squared plus negative 4.85 squared. And we're going to plug this into our calculator. And a good practice is to always have all your digits, basically. You don't want to round until you get to the last answer. So what I'm going to do is I have this square root here of, and I'm going to like basically copy and paste that number. And what we get is 50.8. So that's our answer for the magnitude, which is like the length. But we're not done yet. We still have to find this angle, the direction. So how do you find theta? So earlier, it all goes back to this. We learned tan theta equal to a over b, which in this case is this, the y side divided by the x side. So how do we do this? Tan theta equals the y over the x, because this is y and that's the x. So like right here, and this is theta. So it's going to be the y over the x. So what's y again? Negative 4.85 divided by x is 50.61. So how do you find theta by itself? Of function. So basically what that means, you do something to this thing and it'll spit out a number. So if you want to get the original thing, you'll have to use like the opposite thing. So like if tangent was like a machine and it does something to a number, you put this number into the tangent machine and it spits out another number. You need something called like an inverse tangent machine to put it back to the original number. So in this case, the inverse tangent machine is actually called inverse tan. So this basically undoes the tangent thing. So if you do the inverse of one side, you need to do the inverse of the other side. So what you get is negative 4.85 divided by 50.61, and you get the inverse of that. And luckily, we don't have to figure out how to do that by hand because we also have a button right here, the inverse tangent button, right above the tangent button that can help us calculate. So I'm going to do the same thing where I copy and paste the values so I keep all the numbers, all the digits. So this is the opposite divided by answer that we get is negative 5.47-ish. Our final angle represents this triangle, this vector. So that equals, what was it again? Negative 5.47, so negative 5.5 degrees. That's because, as you can see here, this angle is below. So once you go below, you're going in like the negative direction. So yeah, that's how you describe this arrow. And that's it for today. Thank you for coming to all my classes. If